Hello.
Nodes are not visible.
Mm. Okay, let me disconnect and again join from that application only because here I won't able to share my screen. Hey team, may I audible?
Yes, sir.
Okay, so let me quickly share my screen. So my screen is visible now.
Yes, sir.
Okay, that's great. So before going forward, let's discuss what we had discussed in last two sessions quickly. Just quick recall from your side. Anyone can recall?
Sir, in previous session, we have discussed about macroscopic efficiency and microscopic efficiency. Then we have talked on capillary pressure. Then in last session, we have discussed about the water flooding. In
Yes,
that, how it will work for means pressure maintenance and which
yes, yes. That's
heterogeneity effect.
yes, yes. Okay, okay, okay. Understood. Okay, so we did not cover gas injection, correct?
Yes, sir. No, sir.
Okay, 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 okay. Milind, thanks. So we can start from gas injection today. So as we have already discussed regarding recovery and impact factor, the factor which impact on recovery, then efficiency, types and kinds of efficiency, then about the water flooding and the how water flooding works, how profiles changes, and the relative terminology related to water flooding and EOR. Okay, so today we will start with the gas injection. So today we will cover two topics, and these two are again techniques of EOR, and they both techniques are correlated with each other, and we see the principle behind gas injections. It is not there is no any difference between what gas injection and water injection. So just we have to understand where we can inject gas and where we can inject the water and in which conditions. I think I told you the condition at which water flooding is more suitable. May I told you that, or may I tell you the
No,
conditions at which water
no, sir.
inject in, like in terms of higher initial water or free gas available? I think
No, sir.
I'm okay. So we did not cover where to use which gas injection and water injection. Okay. So we discussed regarding profile, like how front will change and piston kind of effect we can observe while water is pushing to oil. Okay. Still that we discuss, correct?
Yes, sir.
Okay, so we can continue from that. So today we will cover this gas flooding and concept of miscibility. So today itself we cannot cover entire miscible flooding because it's a huge topic and you can see many theoretical questions from this miscible flooding. So we understand miscibility concepts which helps to or which can assist to understand miscible flooding in a proper manner. So at starting, uh, so let's talk about gas flooding words. So as we discussed regarding the water flooding, there is no difference in this. Again, we inject the gas at a continuous rate, and it will, like, there are two mechanism happens during the gas flooding. The first mechanism is the whatever gas is there, if the pressure is above the bubble point, then it will reduce the density and viscosity of crude oil because it will start to dissolve inside the oil, and oil viscosity will decrease. But if pressure is less than bubble point pressure, then the gas will push the oil towards the production well and the oil will produce. So shall I want, like, I would not like to draw that profile again, but you can assume as similar as how water flooding was working. Here the major difference is gas is lighter in nature, so the efficiency which we get during this gas flooding is much lower. I am talking about the microscopic efficiency, like contact area may be similar, but the whatever contact throughout the contacted area, the amount of oil produced may be less in case of gas injection, because water is viscous and gas is a less you can consider in that way. So the mobility ratio here we can observe greater than what we can observe during that water flooding case. Okay, so is this clear to all of you why microscopic efficiency is less?
Yes, yes, sir.
O- okay, good. So the another difference here is we can inject gas either into oil zone or either into the gas zone. We cannot inject gas into the water zone. Okay, so that is self-explanatory and no need to explain that. But when we inject a gas into oil zone, it will try to dissolve inside oil if pressure is above bubble point pressure, and if pressure is already less than bubble point pressure, then we inject gas into gas zone only. Then and then gas cap works, and in first case, solution gas drive may come into picture. Okay, so this is the basic concept and idea behind the gas flooding. Here again, the major concept is we want to maintain the reservoir pressure so the oil can easily flow from reservoir to the wellhead. And this is when I say gas injection, it means it's a immiscible gas injection. That means gas will not miscible with the oil, and it separately works. Not it's not a part of oil phase. We will discuss that in miscibility a lot. So that is first point how gas flooding works. Okay, so hope you all understood that. Let's come to second point, advantages and disadvantages. So when we are talking about actual field work, so in that case the cost come into picture. So in case of gas flooding, we require like gas injection is not that much easy. We required you can say heavy compressor or something kind of that. So capital investment obviously higher, and as we already discussed, the microscopic efficiency what we can observe with gas flooding is lower than the water flooding. So to select a proper method is always essential in terms of pure techniques. Okay, so the next topic is how can we decide whether we select whether can we go with water flooding or gas flooding. So there are two criteria. So we can start from here today. How to decide? Okay, so we can prepare the note for that. Okay, so like disadvantages, you can understand there is nothing that much. So
Hello, sir.
that yes,
Sir, in microscopic efficiency, which flooding is beneficial or benefited?
in case of microscopic efficiency, when we say microscopic efficiencies, directly deal with a mobility ratio. Okay, or we can say the
Okay, okay.
whatever capability water has to displace the oil from the whatever the area contacted by the water, uh, and the ability what gas has between those two, the water is more that have a capacity to drive the oil. And we already learned that water drive and gas cap drive. Okay, so which one is more efficient? We know that thing like water drive is the more efficient than the gas cap. So at that also we can observe higher recovery. Same concept is applied to here. So basically we are talking here is the water drive and gas cap drive only. Okay.
Okay, sir.
Okay. And regarding advantages and disadvantages, like there is nothing much into that. Water flooding has already advantage in terms of efficiency and cost, so that we want. But there are certain cases where water flooding is not that much suitable that we are going to discuss in top three. Okay. So case one, I'm writing case here. Case one. Let's suppose you have a higher free gas or another case is lower free gas. That means our reservoir pressure is already below bubble point pressure, and this pressure is not that much helpful to flow oil from reservoir to wellbore. In these cases, in these two cases, like in case one, when we have a higher free gas. So as we know, if we have a higher free gas, then what do you think? Which flooding shall we use?
Gas flooding, I think,
In higher free gas, which flooding we can use, and in lower free gas, which flooding? And tell me reason also. That makes sense.
because
Okay. Yes, yes, go ahead.
because sir, if we have a higher free gas contained in a reservoir, so whenever at whatever time we are injecting gas into reservoir, so it will pushes this oil with higher grade. Means there is also free gas present, and we inject more free gas. So there is more free gas in the reservoir, and it will pushes the oil towards the wellbore, I think.
Okay. Anyone else? Any other view on this? Anyone? If have?
Sir, in the higher free gas reservoir, we cannot inject the gas because it is enough for the recovery of the gas. We
Okay.
have to use the water flooding.
Okay. So, do you think why we cannot inject a free gas in within a free gas already exists? What should be the reason? And whenever this kind of reason, if anybody is asking you, na, just think about rock and fluid properties. That is the only way to answer this kind of question, and that is the correct way to approach this. Like in MCQ, you already have that option, so you can think in that way only. But let's suppose if you are facing an interview and suddenly this kind of question, if somebody is asking, then just think about fluid and rock properties. That is well sufficient to answer these kind of questions. Okay, so the first approach we like, I think Milin told, and second approach who told that? Arpit or Pranav?
Yes, sir.
Arpit.
Yes, sir.
Okay, so Arpit, you are correct, but you are not able to catch the correct that reason. So let's suppose this is a rock. Just tell me this answer. We are talking about reservoir engineering only here. This is rock, and in the like, let's suppose this is oil plus gas zone only. Below this, we may have a oil plus water zone. Like we have a gas zone, oil zone, and water zone, something like that. And let's suppose here we have a gas, and we want to produce this oil. Let's suppose there is nothing to inject here. We are not injecting anything. Just we want this oil to be recovered as a naturally. So let's suppose from here this oil is present and gas is present, and let's suppose which can flow easily in this case, and why?
If the sir higher amount of gas is present, then gas cap drive will be active.
Yes.
Then oil will be producing because water is because rock is already water wet. So oil will
Yes.
produce.
Uh, is this in this zone? Is this rock water wet or oil wet? Let's suppose water is not present here and oil and gas is only present. Then most of the cases, which kind of wettability we can observe here?
Oil wet.
Yes, it must be oil wet. Okay. And in oil wet cases, which can flow easily, oil or gas?
Gas.
Okay, so gas can flow easily, but do we want that gas can easily flow and it will start to produce? No.
No sir. No.
So definitely whenever we have a higher free gas, I'm talking about free gas. This free gas means it's already dissolved inside the oil when the pressure is above the bubble point pressure. It started to become a free once the pressure drops to the below bubble point pressure. Okay. So in higher free gas, we already know the rock characteristic is toward the violet side, and we don't want that. So in higher free gas, we can inject the water, so that may produce. Like here we have a water, and if we inject this water, and let's suppose in this zone higher free gas were present. So actually, I had to represent this like this. I have to show mix with oil and gas. Okay, this is correct. Now you can understand. In this case, if we inject this water, so in this case what's happening, let's suppose this rock become water weight now. Okay, I written here gas plus oil. Okay, so free that only gas zone may present above this level. So if we inject the water here, so this rock become water weight, and two drives simultaneously may act. That those two are gas cap drive, secondary solution cap drive you can also say, and water drive. So in this case we can inject the water, not the gas. Okay. So in case of higher free gas, which has a higher priority to inject? Water. Okay. But let's suppose if same case we can think, let's suppose if initially higher amount of water is present, that means the rock is already a water weight. Okay. And in that case we can inject the gas. So another case too I can write, when higher water is present. So in that case gas can be injected as a priority. Now, who decide the threshold in terms of saturation for this? Definitely, domain expertise can decide that. And this domain expertise may not come within a 1 or 2 year. It comes after 10 or 15 year, or may take 20 years of experience in actual field. Okay, this is the case with industry also, practical case with industry. And the let's suppose if water is low, then we can say water injection is more recoverable. And here we can say another case with higher water present, it can break through early. Okay, same case with when higher gas is present, and if we are injecting the gas, then gas can it can break through, and breakthrough is nothing. Whatever we are injecting start to produce, that means it's a breakthrough. Okay, so यहाँ तक clear है or any question with this? Hello.
सर
Yes.
सर अभी जैसे आपने बोला कि अब रिजर्वायर में सिर्फ ऑयल और गैस प्रेजेंट है, तो मतलब ऑयल ऑयल वेट होगा नहीं। और फिर जब हम उसमें वाटर इंजेक्शन करवाते हैं तो रॉ का वाटर वेट बन जाता है।
Definitely, oil and water among the between the oil and water, which has the higher priority to wet the surface. Definitely, water has that. Let's suppose here we are not considering any other material are present, such as surfactants and alkaline material, because this material can inverse the wettability of any rock that we will cover in that surfactant injection and alkaline injection. But uh, in generally, uh, most of the rocks are this water wet. It may be exceptional cases in case of carbonate rocks. There are many carbonate rocks which may initially oil wet even if water is present, but we are not considering that here. We are talking about in general terms. Okay.
ओके सर।
Yes, but this is the logic which can support our answers. Okay, like higher water is present, then it may break through early because of the water. Water in case of gas injection, the uh, higher water is present, then the rock becomes the water weight, and gas may act as a gas cap drive, and it can push the oil efficiently than compared to lower water present, because in lower water rock becomes oil wet, and when the rock becomes oil wet, in that case it can like gas can flow easily from larger pores. So our objective is to flow oil through the larger pores. Okay, it's related to that relative permeability curve also. You can understand it by combining these two concepts. Okay. Any other questions on this? So I'm talking about free gas. Okay, I'm talking about, let's suppose free gas is already present in higher amount, or I'm talking here about the initial water which present maybe in terms of cornet water or in terms of free water also. The so hope you understood this. So can we go ahead?
Yes, sir.
Okay. So another thing is here. So have you guys during your courses of BTech have you heard about this terminology viscous fingering? Hope you heard in reservoir.
Yes, sir.
So what is viscous fingering?
Sir, means fingering means whenever we are injecting some water or gas, so how it will spread, how it will push the our oil. So means in aerial way or something like that. Means how it will pushes the oil, how the figure show. I think
Okay, but do you have any proper definition when this phenomena can occur?
no, sir, no.
Okay, anyone has that?
नो सर।
Okay, we will cover it. So this question can directly ask into gate, and it already asked in 3 times, more than 2 times I know. because I even whenever I attempted the paper, this question came. So the basic when the viscous fingering occurs and four options are given. So viscous fingering. So first of all, what is fingering here? Okay. So fingering means nothing. So we know how. Let's suppose this is the area. We have a oil here and we have a water here, and we are injecting water also. So how does it change? It start to change like this. Let's suppose it come like it create a front, and from this front it push the oil, and water is behind this. Okay, so it try to cover maximum area as possible. Okay, this we know. But let's suppose this kind of profile, rather than creating this kind of profile, if water pass through like this, not as a piston. Let's suppose we are injecting water here and we have a oil here, and this is the water. And let's suppose this water tries to produce from here. Okay, water start to produce. Okay, oil is left behind. So यहाँ पे oil बच गया है और water ने produce होना start कर दिया. Okay, so this is known as simply viscous fingering. Okay, so do you think when this kind of phenomena can occur now? Like water is not affecting the oil is on its own space and water just passing from the oil. ऐसा कब हो सकता है? Just don't think about
If
water and
we
oil. Yes, go ahead.
hello,
Yes, go
sir.
ahead.
Whenever sir, if we have a oil weight rock and
Yes,
we are injecting water, so
yes,
that might be there. So there might be possible of viscous fingering, and if we got early breakthrough time,
yes.
so that
Okay, so that may correct here. Uh, like whenever we have a oil weight rock, but whenever we have a oil weight rock, in that cases you already know whenever the larger courses are there, in that water can pass, in water can occupy that larger spore spaces, and oil occupies smaller spore spaces. But when water start to push the oil, here we were talking about the residual oil. Okay, like we don't want higher residual oil. That means कि let's suppose what rather than becoming a water weight rock, the rock is becoming the oil weight, and in that cases, if gas is present, then gas cannot able to produce entire that. Like definitely in that case, the residual oil saturation is higher and recovery will be low. Here, what we are talking here, we are talking about the flowability content. Okay, so in this case, don't connect wettability here. Just think about density, viscosity, something kind of fluid properties. Let's suppose I would like to fix this. Let's suppose my rock is water weight itself, and let's suppose consider the caveats here. Like my rock is water weight in one kind of situation, I am getting this kind of profile, and in another kind of situation I am getting this kind of profile. Then if rock is oil weight, then definitely we cannot inject the water in that case. Okay,
okay, sir.
so that's the meaning here to understand viscous fingering. So let's suppose this both the cases are for water weight only, then can you think? बहुत easy है, let me give you the hint. लेट्स सपोज तुम
Hello, hello, sir.
यस यस
सर हम अगर सपोज हमारे पास ऑयल जो है रेसिड्यूअल, उसकी विस्कोसिटी हाई होगी, उसके लिए ही तो वो प्रोड्यूस नहीं हो पा रहा है.
यस एंड
तो
व्हाट
तो
द
वाटर की
अदर
विस्कोसिटी कम
yes, correct, correct, 100% correct. ओके, सो लेट सपोज कि जो डिस्प्लेसिंग फ्लूइड है, यहाँ पे हमारा जो डिस्प्लेसिंग फ्लूइड है उसकी विस्कोसिटी बहुत लो है. ओके, एंड जो डिस्प्लेस फ्लूइड है उसकी विस्कोसिटी वेरी हाई है. हियर वी आर टॉकिंग अबाउट विस्कोसिटी ओनली. Or this is the oil, so you can say higher viscous crude has a higher density also. That might not case be with all of the time. सो सिंपल थिंग व्हेन जब हम जिससे हम धक्का लगा रहे हैं वो वाला फ्लूइड बहुत ही लोअर है डेंसर नेचर में, और जिसको धक्का लगा रहे हैं वो वाला ज्यादा डेंस है. सो इन दिस केस व्हाट विल बी द इम्पैक्ट ऑन मोबिलिटी रेशियो? What is the formula for mobility ratio?
K by mu. K are relative permeability.
Yes. What is the? I'm not talking about mobility. I'm talking about mobility ratio. So this is the
K R
formula.
W by K R O into
Yes,
mu O by mu W.
yes. So this is the correct one. And we can say that let's suppose mu high है. Okay, mu क्या है अपना high है, and ये वाला mu W क्या है low है. So in that case, what will be the impact on mobility ratio? It becomes very high. Okay. So this phenomena is known as the viscous fingering, and which kind of profile we can get in this case? This kind of, okay, where we can see fingering kind, like what we have in our hand, fingering kind of impact, and water can early break through than whatever than these first cases. Okay, so here we can observe that in this case we cannot get that much recovery. So this is the important phenomena in petroleum industry, and it has observed then and then it is discussable. Okay. So while we are injecting the gas, so many times gas is a very lighter and maybe the crude oil is the heavier heavier one. So there are chances to occur this phenomena in case of gas injection. Okay, so that is again the disadvantage of whatever we are injecting as a gas. So this one is the major disadvantage of gas injection, you can say that. But let's suppose my crude oil is very light, or we can say similar compositions of my crude oil with that gas. Just give me a minute, guys. Give me 1 minute. Okay. So this is the another disadvantages with the gas flooding. And same we can consider. So here we can connect with the API classification of crude oil with the recovery factor. Okay. So any question on this?
No, sir.
Okay, it's easy na. This EOR is simply just you have to connect the whatever you have learned in that reservoir with these methods. So I don't think it's very hard or something like that. Everything whatever we are discussing here is a logical kind of things. There is nothing to mug up with this subject. Just exceptional cases are there. You have to mug up the polymer name, like 2 or 3 polymer name and their advantages, disadvantages, and nothing else to mug up. Okay. So let's start to discuss let's move on to the next topic. So the next topic is the miscibility. So here till here we have covered the gas injection and water injection. So gas may be a miscible or maybe immiscible. So till here we have covered the immiscible gas injection. We did not discuss about the miscible gas flooding or miscible gas injection. Okay, so when mostly whenever I'm saying gas injection, just consider this gas injection is as a immiscible gas injection. And when I say miscible flooding, that means in that case again we are going to inject the gas only, but this time the whatever mechanisms inside the reservoir is just a different and than whatever we discuss in gas injection. Okay, so now from now we consider three terminology: water injection. So oil has not characteristics, it cannot miscible with the water. Why? We can discuss in what is miscibility topic. Another thing is gas injection, which is immiscible gas injection, and third topic is miscible flooding. Miscible flooding is just a miscible gas flooding. Okay, so till here whatever we discuss, any question, any doubts, anything you want to add, or any new thing which you want to know and I forgot to tell you, just let me know.
Hello, sir.
Yes.
Sir, you are told in viscous fingering, okay, and I got all the thing. Means suppose we are injecting gas in comparison with water.
Yes.
So, sir, what is there a viscous fingering will occur or it will not occur in oil reservoir if we are injecting gas?
Okay, let's suppose you are injecting gas in case of black oil. Okay, so there are chances if gas viscosity is not sufficient, then gas may not push the oil correctly. But gas viscosity is again depend on temperature and pressure, and you know that thing. Do you know how gas viscosity behaves with pressure? Oil viscosity
Yes, sir.
behaves
Yes, sir.
above bubble point pressure. The oil viscosity will decrease with decreasing pressure, and below bubble point pressure, decreasing the pressure, increase the oil viscosity. And you know why it's increasing and why it's decreasing. But do you know in case of gas at a constant temperature, how change in the pressure can impact on gas viscosity?
Means, sir, if we are means what that pseudo real gas potential or
No, no, I'm talking about at a constant temperature. If I'm reducing pressure of gas, then how viscosity of gas change? Can anyone answer what I'm saying? At a constant temperature, let's suppose I'm decreasing the pressure. Okay, गैस का प्रेशर मैं क्या कर रहा हूँ, डिक्रीज कर रहा हूँ, तो विस्कोसिटी क्या होगा, इंक्रीज होगा कि डिक्रीज होगा?
डिक्रीज होगा ना सर.
भाई
मतलब प्रेशर हम घटा रहे हैं तो उसके मॉलिक्यूल भी दूर जाएंगे ना, तो उसकी विस्कोसिटी कम हो जाएगी, वो इंटरमोलिकुलर फोर्स कम हो जाएगा.
yes, yes, correct, absolutely correct. So definitely this viscosity will start to decrease, it becomes easily movable. Okay, so again pressure comes into picture here, but let's suppose both are, we can consider both parameter are constant and we are comparing water injection and gas injection with respect to oil type. Okay, in oil type you can consider two kind of oil. Let's suppose black oil, and another oil is, you can say, light oil. Very light oil similar to gas. Gas may have a composition which has similar to light oil. Then in that case you may not observe that much viscous fingering. Okay, but in case of black oil you may observe gas viscous fingering.
okay, sir.
Understood?
Yes, sir.
We discuss about in which kind of oil which method we can use. In case of black oil you can use this water injection prior to this gas injection. irrespective of whatever other parameters are there. Okay, दैट मीन्स कि और पैरामीटर को तुम नेग्लेक्ट करके अगर बहुत ज्यादा विस्कस ऑयल प्रेजेंट है तो यू कैन इंजेक्ट द वाटर ओनली. ओके, in like this is kind of trial and not we can say trial and error because we cannot invest that much amount of cost in terms of injecting, but you can say you can think in terms of combination and permutation. Okay, and you can choose the method, and I already told you it's required a domain expertise, then and then you can take the decisions. Okay, even so now you have to just think which parameter impacts in which way. Okay, that is well sufficient for you for a gate examination. And you can again read this all from that book which that already sent to you in group. I think someone sent the book. I'm late in. Okay. So any other questions or anything? Let's suppose you are not understanding properly within a concept of, so just let me know. Because today we are covering very less topic. I think miscibility. Okay, we have a 5 topic in that, but we have already covered this 4 topic within a hour. So we can discuss if anything you want to know or whatever thing you want to repeat from my side. So regarding to water flooding and gas flooding, based on the free water available, based on the free gas available, based on the reservoir, I can say reservoir type, whether it is undersaturated or saturated, based on the property of crude oil, such as whether it is kind like API classification, you can consider in that case, and based on the like depth is not a critical, already we had discussed that with water flooding selection criteria. So depth again not critical. Thickness, yes, we already discussed I think this, like in smaller thickness we can use gas flooding in place of water flooding because it can easily mm, pass through that session. Then another criteria is rock type is not that much effective here, like we can inject both with water and gas with carbonate and sandstone. Then what we can say, temperature is not again critical criteria, pressure is not again critical criteria here. Okay, so these are the screening criteria. So I'm covering this all screening criteria by explaining each of them in terms of reservoir rock and fluid properties. So just any doubts or anything you want to know, else we can move forward to miscibility topic.
No, sir.
No? Okay, good. So just try to read these 2 topics from that book. You will have a time till tomorrow class. So tomorrow is again Sunday, and I don't think after this lecture anyone you would like to read. But just try to read those at least first or 2 chapter, not first or two, water flooding theory and gas flooding theory from that book, or you can follow any other book also. It is good. Like you now you can you when you go through that book now you can understand that this easily, like whatever written inside that book and concepts. Okay, and any doubts you can note it down and you can ping me, or you can, like we will discuss in next lecture only. So now let's discuss about miscibility. So to understand miscible flooding, you first have to understand miscibility concepts, and it's very easy. It's a 12th standard, or you can consider 11th standard question. What is miscibility? Anyone can. I don't want definitions like when. Okay, so I told you one thing. Can anyone tell me what is the difference between equation of state matter and state of matter, not equation of state? Sorry, I told you some little bit wrong. state of matter and phase. What is the difference between state of matter and phase?
Sir, state of matter means solid, liquid, and gas. And phase means in that phase there is a chance of one phase or two phase. Means occurrence of a phase when two liquid that are immiscible together. Okay, so there might be possible that two phase is occur when two liquids are immiscible, and that if that two liquids are miscible in each another, so that there might be possible one phase liquid.
Okay. Anyone else want to elaborate what he said? Like this, I already told you during that lecture only, na? How will you define equation of, state of matter versus phase?
There, I think there is a one rule F is equal to C minus P plus 2
That is the
to
degree of
define
freedom.
phase.
This rule, okay? This is nothing, this degree of freedom. So let's talk little bit on this. So this is the most important topic. This may ask you in GATE examination directly, just calculate degree of freedom, or may ask you what is F, like any value of this by giving this degree of freedom. But that we will cover a little bit later on. Let's talk first of all state of matter and phase. Okay, so as already he mentioned, there are three kind of state of matter exist, but actually it's not a three, it's a five. Total five state of matter exist. Two are not important that much, but for your information, I'm writing all five. We know solid, we know liquid, and we know gas. This is the plasma and B condensate. Okay, we never discuss regarding to this. This is the question of 12th board and 10th board during our board exam. But we always discuss regarding these three: solid, liquid, and gas. When I say phase, within this solid, what we are doing, we are subtracting the substances which are unique, or which we can say uniform in terms of properties. That is known as the phase. Okay. Same we can do with liquid phase also, and same we can do with gas phase also. So when I say phase, let's suppose this is a phase one, liquid phase two. That means that liquid phase one contain some kind of uniform properties. Uniform means it's a uniform, it's kind of homogeneity throughout that phase. Okay. So which kind of property I'm talking here? I'm talking about density, this kind of properties. Okay, fluid properties. So now you may understand what is the difference between state of matter and phase. When I say state of matter, it's define the state, whether it is a solid, whether it is a liquid, whether it is a gas. But when I say phase, it is the uh, it is uh, it is the more elaborated that state of matter in terms of uniform properties. Okay, so this is the basic difference between state of matter and phase. So I when I said this is a liquid phase one, this is the liquid phase two, they both phase may exist immiscible, they both may exist in terms of miscibility, and but what we can say that particular phase has their unique characteristics in terms of properties. Okay, so hope this is clear. Any doubts in this?
No, sir.
Okay, good. So have you understood this? What is difference between state of matter and phase? Minor difference, but whenever you are reading the books and if it is written as a phase, then you should consider it may exist liquid phase one and liquid phase two simultaneously within a particular mixture. Okay, not a mixture, solution. Sorry. Okay, mixture is a kind of different things and solution is kind of a different things. So let's move forward for further. Uh, so if you understand this phase, can you tell me the two important properties which define the phase?
The pressure and temperature.
Yes, very good. So there are two properties, pressure and temperature. These two property define which phase my liquid can have has, okay, which phase my liquid can has. So pressure and temperature, let's say I am saying, consider water for now, okay. So water, when I say water, it's H2O. Okay, so it's a single substance. I can say it's a single substance. So there are not possible. It's a equation of it comes into liquid, and this is water is a phase. That means it has a unique characteristics. Let's suppose 1 atm is the pressure. Okay, and its temperature is, let's suppose, 100 degrees Celsius, then can you tell me the phase name in which phase this water can exist?
Means, sir, it is 100 degrees Celsius, so that might be gaseous phase.
That not might be, it must be in a gaseous phase, na?
Yes, sir. Yes, sir.
Yeah, because we know the boiling point of this water, na? It's 100 degrees Celsius only.
Yes, sir.
So it is in the gaseous phase only. What do you think at 90 degree? Is it entire liquid or is it a entire gas, or consider for a now boiling point of water is 100 degrees Celsius. Does it in entire liquid phase or does it in gas phase also? बहुत सिंपल है यार. तुम घर पे कितने टेम्परेचर तक पानी गर्म करते हो? Obviously I'm talking about 1 atm temperature. That means itself I'm talking about natural life. Which phase shall I write here, liquid, gas or liquid plus gas? ओके, और थोड़ा तापमान नीचे लेके आओ. 80 डिग्री पे क्या होगा?
Hello, sir.
यस.
Sir, if we are continuously heating the water, so two phase will exist, means liquid and gaseous.
यस, डेफिनेटली वी नो दैट एट हम नहाने के लिए पानी गर्म करते हैं तो उसमें से भाप भी निकलता है, दैट वी नोन एज अ वाटर वेपर.
Yes, sir.
यस. सो एट बिलो बॉइलिंग पॉइंट टेम्परेचर, what does both phase can exist, like gas, yes, as well as liquid. Okay, so when I say it's a water, sorry, when I say it's a water, it's a liquid. When I say water, that means it's a liquid. Its define is state of matter, and based on these conditions, phase can be defined. Okay, so you can see the difference between state of matter and phase. So what I want to say here, what is degree of freedom? Any idea? Do you have what is degree of freedom?
Yes, sir.
Tell me.
Sir, means how many parameter we need to identify for that particular system to define it.
Yes, very good. So degree of freedom is nothing. Minimum parameter. It's a thermodynamic term. Minimum parameters required I'm writing this definition. Just wait for 2 minutes. Just complete this namaz. Okay, you can listen the noise maybe. Okay, so we can take a 2 minute break here. Then we will continue. 5 minutes break we can take. So we can continue from 7:05 till that this namaz will complete. Okay. Are you able to follow me?
Yes, sir.
Okay. So any doubts still here? I already asked to you, but even if you want to know anything, then you can ask me during these 5 minutes.
सर
Yeah.
आपने बोला था कि हम इंजेक्शन करवाते हैं वाटर का विस्कस फिंगरिंग में, तब वो वाटर प्रोड्यूस होना चालू जो हो जाता है, लेकिन ऐसा हो सकता है कि रिजर्वायर में बिना इंजेक्शन के भी विस्कस फिंगरिंग हो जाए?
Yeah, it's possible, but let's suppose ऐसा इसलिए मैं नहीं बिलीव करता कि होगा बिकॉज यू नो दी लेट सपोज कोई लाइटर क्रूड है, लेट सपोज क्रूड ऑयल हैवी है वाटर से भी, ओके, तो इन दैट केस द buoyancy ऑफ वाटर कैन गो अप ना. So already the water should be above the oil, not oil should be above the water.
यस सर.
That is the case also possible na. But still we did like all over the world अभी हमने उतना हैवी ऑयल को वो नहीं किया है कभी प्रोड्यूस. ओके, सो अभी यूआर प्रोजेक्ट बहुत सारे चल रहा है. यू कैन सर्च दिस काइंड ऑफ थिंग्स ऑन नेट on ongoing UR projects like for a particular field, not in particular colleges or research laboratories. Okay, so there you can get the information more. And एटलीस्ट अगर देखो कोई ऐसा कंपनी आ रहा है कि जो यूआर में बेसिकली काम करता है, तो कौन सी रिकवरी मेथड कितना परसेंटेज थ्रू आउट दी वर्ल्ड यूज हुआ है, कौन से मेजर प्रोजेक्ट है, ये सब थोड़ा बहुत पता करके जाना. आई विल शेयर वन डॉक्यूमेंट विथ ऑल ऑफ यू, उसमें लिखा हुआ है ये सब. यू कैन यूज दैट एज अ रेफरेंस, बट इट इज बेटर टू सर्च ऑन नेट. ओके, बट अगर नहीं आ रहा तो कोई एक्स्ट्रा एफर्ट से वो रटने की जरूरत नहीं है.
ओके सर.
Yes. I think it is completed now. So, are you able to hear that noise of Namad?
No, sir.
Okay, actually it's a too much noise. अभी थोड़ी देर बाद आरती start होगा. So here Indo-Muslim kind of thing is that we have a fraternity with all of us. So there are as many as number of temples, as many as number of masjid present in this area.
सर,
Yes.
how can we how can we differentiate saturated vapor and saturated liquid?
Oh, good question. Uh, so we will talk about two-phase pressure versus volume diagram also in this topic.
Okay,
Or you can do
sir.
one thing now, with just once go through the reservoir section in my YouTube channel and just go through the first video of phase envelope, or where I have explained the pressure versus volume. Or let's discuss today itself. We will have a time, enough time to discuss that. Okay. Uh,
Okay, sir.
do one thing now. We will keep it in last. I will explain this concept in last. So let's
Okay.
continue with the flow, and I will explain that in last little bit. Not little bit, I will explain thoroughly. Okay. So let's continue with this. Uh, so what we are discussing here, minimum parameter required to define any system, okay, at a given situation. So let's suppose I want to define this phase, whether my water is in a gas or liquid. How many parameters I required? One and two, correct? Is it correct?
Yes, sir. Yes, sir.
Yes, if I know temperature and if I know pressure, I can define this. Let's suppose question is like, find degree of freedom at 280 m and 100 degrees Celsius for hexane. You know hexane all?
Yes, sir.
For the hexane, and let's discuss first degree of freedom formula. So degree of freedom formula, you generally look into many books. It's written something like this. Phase, आई थिंक कंपोजिशन माइनस फेज होता है ये, कंपोजिशन माइनस फेज प्लस टू. ओके. कंपोजिशन माइनस फेज प्लस टू होता है कि
Yes, sir.
फेज माइनस, करेक्ट है ना ये?
P minus P plus 2. Yes, sir. Correct.
सी माइनस पी और पी माइनस सी.
C minus P, sir. Correct.
Okay, okay, sure. Okay, thanks to confirm. So degree of freedom formula is a composition. uh, Composition, this C means composition. Okay. यहाँ पे लिखते हैं हेक्सेन एंड हेप्टेन. which which are in liquid and gas, which are in liquid. Okay. So if this kind of question given to you, and let's suppose this kind of formula is given to you, C means composition, phi means phase. Okay. Number of phases. So this number can go 1, 2 and 3. Okay. And this composition may have a 1, 2 up to n. We consider here state of matter, not that one. So keep in mind that thing, or I will give you the confirmation regarding this by tomorrow. Whether we consider two liquid phase if exist, then we can consider them as a separate, or we can consider them as a liquid only. But whatever I recalling, we can consider this as a 1, 2, 3. Like if two phases, let's suppose here hexane is again in a one liquid, like this hexane and heptane. Among these two, let's suppose hexane in liquid phase 1 and heptane in liquid phase 2, then we consider p value as a 1 only, not a 2, not that different 2. Okay. But I will give you confirmation on this, but generally we consider like this only, and in this question you do not require to think about that because I already told you hexane and heptane both are in liquid phase only, same liquid phase. So can you give me the answer? What should be the answer for this? C is the composition, P is the number of phases, 2 is the constant. So what is the degree of freedom here? कम ऑन गाइस, इट्स इजी, फॉर्मूला भी दिया है और ऊपर से जस्ट तुम्हें वैल्यू डालना है, सी कितना होगा, पी कितना होगा, एंड व्हाट शुड बी द आंसर.
सर 1 होगा ना.
ओके, सो व्हाट इज द वैल्यू कंसीडर फॉर सी?
2.
2. Why? Hexane and heptane. Okay, so C is equal to
Yes
2.
sir.
It is correct. Okay, it's the correct. What is the value of P here?
Sir 1.
1. Why? Because only liquid phase is
Yes,
existing,
single
not
phase liquid.
yeah. Okay, so consider P as a 1 now. So through the calculation, your answer is equal to 1. Okay, 3. Okay, sorry, 3 na? You did mistake in calculation
Yes.
only na? 2 minus 1. Okay,
Yes.
3. Okay. Uh, okay.
सर
I would
सर
like
2
to
आएगा.
how C is equal to 2, P is equal to 1, then 2 minus 1 is 1, 2 plus 1 is 3. So answer is 3 according to what first guy said. Okay, I won't able to see your name. So uh, how are you saying 2 आएगा?
Sir, I am considering phase 2.
No, no, I told na here hexane and heptane are liquid phase only. I'm not saying both are in different phase. I already told
Sir,
na, for now consider both are in liquid phase only and they have a mixture of hexane and heptane here. Like crude oil, again we say crude oil is in a liquid phase. That means this mixture is in a liquid phase, single liquid phase, not double liquid phase or second liquid phase. Okay.
okay sir.
Okay. What you have to understand here is that uh, let's suppose even this formula is given, then answer is not a 3 here. Based on the formula, you are correct. Answer is coming the 3, but actually answer is here is 1. How? Let's discuss. So you should know the intuition behind degree of freedom. What we discuss here, let me write two more question here. Question 1. What is degree of freedom for a water which is in liquid phase? And question 2, what is degree of freedom for a water which is at 1 atm and 110 degrees Celsius? Okay, give me the quick answer for these two questions. Uh, Definitely in gas phase. Just give me the quick answer for these two. You can answer as per the
Sir,
formula
in
also.
first question it is 2.
Yes, it is a 2 in this. Just I have changed that liquid to gas only in this question. What is the degree of freedom
So
for
2.
water?
2 sir.
What? 2.
2
Okay.
sir.
Okay. But the actual answer for these two questions, for first question the answer is 2, but for second question the answer is 0. Okay. Why?
Yes
What
sir.
does
Because
degree
sir,
of freedom mean? Yes, yes, go ahead.
because sir, we are already define it at 1 atmosphere and 110 degrees Celsius. So we require zero. We require
Yeah.
a zero parameter to define that particular phase.
Yeah. In question 2, system is predefined. That means let's suppose this is a gas, sorry, this is a water state of matter and it is at 1 atmosphere and 110 centidegree. Then we already know that this must be in a gas phases only. Okay. Uh, so we do not require any other parameter here. But in first case, we don't know the temperature and pressure. Here I did not fix any special substances or something like that. So in this case, I can say that the two parameter, let's suppose if I know temperature and if I know pressure, then I can define what is the uh, what is the what is the system here. Okay, I require temperature and pressure value in first cases because I cannot consider temperature value is equal to, let's say, 110 centigrade and pressure is equal to 1 atm here. Okay, so I at least required uh, two parameter. Okay, let's suppose if you are considering temperature below to that, then again pressure is required because based on pressure we can also change the phase. So intuition is saying you must read the equation first, and this formula I would like to modify it little bit, which might not given in the book, but this question is already asked in the chemical engineering gate examination, and during that also they have considered like this only. You have to subtract the spatial instances. Okay, this I say spatial instances, and you also have to minus r. These are the nothing but the number of reactive agent, but this might not case here because we are not dealing with that chemical reaction engineering. You already learned this in your 12th standard, but we are not dealing with that, so this is well sufficient for you. So always subtract spatial instances. Okay, so here again we had two instances, temperature and pressure, so you have to subtract minus 2 in this case also. So based on the formula you got what answer you got? 3, is that correct? But you have to subtract the two special instances here and answer is 1. Okay, so here it's a crystal clear, you required a temperature and pressure. Okay, but here we do not require any. So in this again you can go with the formula C minus P plus 2 minus special instances. So degree of freedom, C is only water, one component, phase is again only gas, minus 1, plus plus 2 minus special substances are given, temperature and pressure is already defined, minus 2, so it's a 0. Okay, have you got this? Any doubts here?
Yes, sir.
Yes.
No doubt, sir.
Okay, so here we already know the temperature, we already know this pressure. Then which one substance require here to define this system? Can anybody tell which one substance is I know for this hexane heptane mixture which is in liquid phase at a given temperature and pressure? So I can define this system. Can
Sir, I
anybody?
think a boiling point.
Why boiling point is required? It's already in liquid phase, so I can say 100 degrees Celsius is the temperature above the boiling point. I do not require boiling point to define this. What information I get? Okay, just think what is the difference when we have a hexane and heptane and when we have a water? Only water versus hexane plus heptane. Let me give you a hint. Have you gone through the place calculation?
What, sir?
Place calculation.
Yes, sir. Flash and fire point.
What? Place and no
Flash
no no
and
no
fire
no
point.
no place calculation in reservoir engineering.
No, sir. No.
No. Okay. So the if we know one substance which is I can say hexane composition, or heptane composition. Among these two, if any one, if I know this, then I can calculate this, or if I know this, I can calculate this. So composition is the parameter here because we have a two substance here. Okay, we don't know at a given temperature pressure what is this percentage of this hexane in a liquid phase, what is percentage of heptane is in a liquid phase or vapor phase. Okay, that composition we should know here. Then we can define this system entirely. Okay. So place calculation like this, all things are already available in reservoir engineering videos. So you can go that for a more that thing. So I would like to come back to your. Uh, so next topic is, so we are discussing here what is miscibility. Okay, so we not yet reach for miscibility definition, but at least you have an idea what is degree of freedom, what is phase, and what is state of matter. Correct for now.
Yes, sir.
You can go to the next level of this as a place calculation which is already available, or I think vapor liquid equilibrium you can get that in my reservoir sections, and in that also you will have an idea regarding saturated liquid and saturated vapor. I think today I might not cover that, but let's suppose tomorrow I may cover that. Okay, if you want. Okay, Arpit, so you can go through that. Even if you are not getting anything, we will discuss that again tomorrow. Okay.
Okay, sir.
Okay. So now let's talk about miscibility. So can anyone define miscibility? Like among these two phase only single phase is exists that I already know. Any other difference like in terms of rock property? Okay, just let me tell you. When interference tension between two phases is equal to zero, we can say that two phases are completely miscible. Okay. So, what are the benefits of miscibility? So, first benefit is we are reducing interference tension to zero. That means we are reducing the impact of wettability, and now that entire phase is a single phase, and we know there is no relative concept here. So, entire phase can move easily. Okay, so this is the major we can say phenomena for miscible flooding. So in miscible flooding, how it works? It reduces the interference tension between two fluid to zero. Like we know 100% efficiency we never get, but we can say in ideal cases interference tension is equal to zero in case of miscible flooding, and that fluid density or viscosity you can say reduce, and that fluid can flow easily. This is the major concept of miscible flooding. Any doubts in miscible flooding concept?
No, sir.
Okay. So to understand this miscible flooding in a more depth, uh, first you have to understand these two things, which are uh, crude oil definition and the ternary phase diagram. So let's start with ternary phase diagram. So have you ever heard regarding this ternary phase diagram?
Yes, sir.
Okay. So phase diagram means it's a relation. It what does phase diagram shows? Phase diagram simply means it's a relation between pressure, temperature, and volume. Volume is nothing but you can say composition, mole fraction, or something content. You can represent volume in terms of many ways. It may be a percentage share of each composition with respect to total composition. It may be a percentage share of each component with respect to total mole of the liquid phase only, or it may be the percentage share of each component with respect to the total mole of the vapor phase only. Okay, so you can change volume in terms of mole fraction, volume, weight fraction, something kind of that things, and you should know how to convert them. Okay. that should be a basic thing. It may be directly asked to exam, like they can ask the PS, then they may ask this kind of question, like just tell me these are the composition, volume, and just tell me this mole fraction, tell me this mole volume, weight fraction. So at least you should know the molecular weight of these at least 7 to 8 crude oil major components, and you must able to convert them into mole fraction, weight fraction, whatever requirement is at that moment. Okay. So here we are going to discuss regarding ternary phase diagram. Before that, let's define our crude oil. So what do you understand by crude oil?
Means, crude oil is a mixture of carbon and hydrogen, and there is a different type of crude which are present based on the API or that.
Okay, so let's not classify the crude oil here. Just define the crude oil. Let me define crude oil quickly. So crude oil is a mixture of hydrocarbon plus non-hydrocarbon. It's not a mixture of carbon and hydrogen. Okay, hydrocarbon is the combination of hydrocarbon and hydrogen. We define something like this, and we say that which are the major non-hydrocarbon present inside crude oil. Can anybody tell quickly?
Sulfur, nitrogen, and oxygen.
Okay, so these are the pure component, but the majority wise it's H2S, CO2, H2O, and 2. Okay, these are sorry, not H2O and 2, CO2 and H2S. Okay, these three are major non-hydrocarbon impurities in crude oil. Okay, I'm saying impurities, that means it has a, let's suppose CO2 has a different property than all other non-hydrocarbon substance, and this property are the exceptional for whichever crude oil have a CO2 and whichever crude oil do not contain that CO2 portion. Okay. In case of hydrocarbon, what are these component present? Can anyone tell?
Means paraffin and aromatic. Cycloparaffin also.
Okay, so that is the SARA classification, you might know. Saturation, aspartame, aromatic, and resins. Okay, I'm talking here about, let's say it's maybe a C1 cut, C2 cut, C3 cut, C4 cut, C5 cut, C6 cut, C7 cut. Okay, so we know till C3 it's always saturated, and after C3 it may be saturated, unsaturated, or it may be mm, uh, aromatic. Okay. So guys, do you know what is saturated or unsaturated here?
Saturated means single bond carbon
Yes,
chain, and
yes.
unsaturated means double bond.
Oh, sorry, sorry. Not a saturated is a proper term because for these two. Okay, C1, C2, and C3. Is it possible to have a double bond with C3 also, na? Like this is not, this is also possible. Okay, okay. So not according to this, but you can consider this as a C1 cut means it's only methane. C2 cut means it's only ethane, or it may be ethylene, or ethane. Well, okay, ethylene is possible things, I think. Propane. But majority wise, these are present: methane, ethane, propane. When I say C1, it can consist only methane. When I say C2, it can consist this kind of structure also. Okay, C double bond C, C3, C4. Then after this, these three are considered, okay, this not these three, these four, five are considered as a, so we can say lighter component, intermediate component, and heavier component. So we can say that this is the lighter, sorry, okay, lighter one itself. Then we have an intermediate component, and we have a heavier component. C7 plus means it may have a C7, C8, C9 up to C40 up to C60. Okay. And based on this, we have a API classification also. Now, when I say I'm representing phase diagram with P and T with entire composition. Okay. So this is with a constant composition. If you look this into 3D, then you can say with composition also you can draw this same diagram. In that case, it's a completely 3D diagram, which might not good to draw here, but it can be possible to draw in 3D also. In 2D, it's something like this between these two. But let's say I want to draw, when I draw this diagram in 3D, xi, temperature and pressure. Okay. So let's suppose in PT diagram, I have drawn this kind of curve. Behind this, I have drawn second kind curve. Okay. So in this plane, this point may we can consider, and from this plane we can have this kind of x versus t, or you can say volume versus t diagram, or t versus volume diagram we can have. So we, when we consider pure component, we mostly study pt diagram and vp diagrams. Okay. So this plane, whatever projection we are getting, and this plane, whatever projection we are getting, we study that diagram, and based on that we can have an idea about this all. But now what I am doing, now I am representing phase diagram based on the composition in a triangular. Okay, and here I have a C1. I will merge this component. Here I have a C2, C6, and here I have a C7 plus composition. And now I will study how phase exists at a constant pressure and temperature with this composition. Okay. Now what I am doing, pressure and temperature is a constant, and I am representing the phase diagram with respect to composition only, and I am studying how my phase will change. Okay. So this is the tertiary phase diagram. So there is nothing to discuss here regarding definition, none of this tertiary diagram. So let's draw one tertiary diagram and understand how, what does it mean. So C1, C2, C6 and C7 plus. When I write C1 here, it means 100% of C1 is represented by this point. If I consider this point, it means 100% methane. If I consider this point, that means 100% intermediate component. And if I consider this point, it means 100% C7 plus composition. Now, this diagram is something like this. It can be represented by this kind of lines. Okay, what does this line means? Okay, if my crude oil is here, that means this is 100% C1. So this is 0% C1, and this is 100% this. So I will draw line from this also. थोड़ा drawing खराब हो रहा है, but just consider for now. Okay, so let's suppose this is 100%, this is 90%, 80%, 70%, and this is 60%. So if I'm considering this 100%, so at this point I can consider this as a 60% of C2, C6. Okay, same case I can draw from here also. ये यहाँ पे ज्वाइन होगा, यहाँ पे होगा, यहाँ पे होगा, यहाँ पे होगा, और ये यहाँ पे होगा. दैट मीन्स 0, 90, 80, 70, 70, 60 एंड 50. That means 50% C7 plus. Okay. Consider any point, and if you want to know the composition of that point with respect to these three, how you can know that? Just draw a perpendicular line from these 3 points. Okay. Anyone have idea how can we know? Let's suppose something, this, consider grid are given, and let's suppose I want to know what is the composition percentage for each, then how can I know?
Sir, we need to draw a line from that particular point to that
Hmm.
edge
Each point.
point of the.
Yes, edge point of the triangular. Yes. Okay, then let's suppose for this point I'm writing this triangular as a B and C, and these are the point perpendicular with respect to this axis to this point with this edge. Uh, then what can I say? Let's suppose E, F, and G. Okay, correct. Then what should be the C1 percentage is? Is it correct?
No idea, sir.
Okay, not an idea. Okay, so simple. You have to read from these axis. Let's suppose this is 100%. Okay, if this is the 100% at this point, and let's suppose I want to calculate for this point, or let's suppose point is point like from this, it may be here, it may be here, it may be here. So how can you calculate that? Just draw the line from this. Okay, something like this. And now you can say, let's suppose if this is length, let's suppose this is x and this is y, and total length is x plus y. Okay, so what you can do, you have to consider this y as a calculation, because here we are considering 100% and here we are considering 0%. Okay, so whatever distance this line has is the actual percentage value. Okay, this is 0%, this is 100%, and whatever this line have, like inverse rule we can say, inverse of that point, whatever distance it covered, that is the actual percentage. We can say this is 70% at this point. Okay, so let's suppose I have a length of this as 100, then length of this is a 70. Same way, if I have a length of, okay, let me draw another figure. This is my point. Then what I will do, I will draw a perpendicular line. I will write it as a EF. Okay, so and this is G. Then what will be the percentage of C7 plus? How can I consider? So if let's suppose this is entire is 100%, then this is my actual X%. Okay, so what can I say? Total is EF length and my length is GF, then I can say C7 plus percentage is equal to GF by EF. Have you got this? Yes or no?
Yes, sir.
Yes. So this is the inverse rule itself. So you have to consider inverse length, not this length. Okay. Why? Because we are considering 100% here. Let's suppose if I have a 0% of that here, but it is not sufficient. Like if this is 0%, then this should be 100%. So it is 100% here and it's 100% here also. So that is not correct way to represent. So there is no any misguidance of or any tricks gate can assume here. So it must be 100% here. So you have to consider inverse length, that should be a percentage, and total length in the division. Similar way you can calculate it for this C2, C6, like consider this length and divide by total length. Similar way for this also. Okay, so you can able to calculate percentage for each. Okay, Now let's discuss more on this ternary diagram. Hmm. So you should familiar with this kind of percentages calculation. Let's go deeper into this calculation because this may ask as a direct question. So I'm drawing here again for your references. So if you are studying again, then let's say this is A, B, and C, and this my point. This is the case, and this is my C7 plus. Then C7 plus percentages is equal to EG divided by BG. Okay, and same way, if this is the case, then if this is C1, then C1 percentages is equal to EF divided by AF. Okay. Uh, so next we are going to discuss about this more. Let me draw complete ternary diagram first. So this is complete ternary diagram with respect to three composition C1, C2, C6, C7 plus. It contains the binodal curve and it contains the plate point. Okay. So what is this curve name? Binodal curve. Binodal curve. And what is this point? Plate point. And we have a tie line here. What are these lines? These lines are tie lines. Okay. And what this curve is and what this curve is, this is liquid curve and this is vapor curve. So we know toward the C1 side we have a liquid vapor here. This is vapor zone, this is liquid zone, and inside this liquid and water vapor both phase are coexist, and this is the single phase zone. So guys, have you studied this in your reservoir subject or shall I explain it?
No, sir. We have learned in previous semester.
Okay, so write down the one question. Uh, just write down one question. Are you able to write? Just collect pen and page if you do not have.
Yes, sir.
Everybody are ready?
Yes, sir.
Okay. Just give me a 1 minute. Or I will do one thing. After this lecture, I will make one question, like one notebook, and I will send. Okay, that will be more better. Okay.
Okay, sir.
Hmm. Okay, then let's go to, it's kind of aptitude question. You have to think, then you can answer. Okay, it's not that much difficult, and if you are not able to do that at a first attempt, just try it at for a half an hour. Don't take more than half an hour. If you are not able to at least generate the logic, we will discuss that tomorrow anyhow. Answer. So let's start with okay, so we know this is single phase zone where only single phase. So I can say this is a miscible zone. Okay, this entire outside of this binodal curve is a miscible zone. This plate point is nothing but it is a similar kind of things with respect to critical points. We can consider this point as a critical point also. This is binodal curve. Like we have a bubble point curve and dew point curve. Same way, this is binodal curve. Here, this is the towards the liquid side, we will have a bubble point curve, and towards that gaseous side, we have a dew point curve. Okay, and this inside this zone, liquid and vapor both phase are coexist. So now, if someone saying at this point, what are the composition for each? Are you able to answer from that line rule? Yes or no?
What, sir?
Let's suppose this is the point A. My crude oil is belong to this point. Okay. So are you able to calculate what is the C1 percentages, what is the C7 plus percentages, what is the C2, C6 percentages?
Means, sir, by previous method we have to calculate, na?
Yes, yes. Like this entire curve is given to you as a, like it is not possible in computer test. But let's suppose if lens size is given, this is the 2 centimeter, this is the 4 centimeter. Then are you able to do that? 4 by 6 is the C1.
Yes, sir.
Okay. Something like that you can do, na? Okay. So this kind of question may ask in the gate, na?
Yes, sir.
Okay. So this you can calculate overall mole percentages you are able to calculate. Okay. Now for each, like let's suppose at this point C1 composition percentage difference, C7 plus composition. So these composition percentages are defined at which phase our crude oil is existing, whether it is in a single liquid phase or whether it is in a single vapor phase or whether it is in a double two phase zone. Okay. So that is the concept here. This is also known as the pseudo ternary diagram, ternary diagram. Okay. Now, what is the impact of pressure and temperature on this diagram? Let's quickly discuss that. So, do you guys know whenever pressure increase for same instant, temperature always decrease? Okay, this is the basic concept or basic thing. Both cannot be increased, both cannot be decreased. Okay, that is like, let's suppose you want to make solid to liquid, then you should increase the temperature or decrease the pressure. So from here itself, while talking about phase, if you have four options and in two options pressure and temperature are going to be increased at a moment, then you can neglect that directly without reading the question also. Okay, this should not be the case. That is, I still here for a single question, temperature and pressure both values never decrease or never increase. Okay, one increasing, then one must be decreased. Let's suppose if you want to know impact of, let's say, surface tension with respect to pressure and temperature. So surface tension decrease with khali, blank increasing decreasing pressure or blank decreasing increasing pressure. Then one is increasing, then another must be decreasing. Okay. So here also, okay, let me draw, and this you should remember. So at a constant pressure, two-phase zone sinks when temperature is decreasing. Okay, so this is curve for 50 degrees Celsius, and this curve is for 100 degrees Celsius, and this is for 80 degrees Celsius. Okay, this is again very important. Consider it as an important thing. And at a constant temperature, at a constant temperature, if my pressure यहाँ पे डिक्रीज हो रहा था तो प्रेशर ऑलवेज यहाँ पे इंक्रीज होगा. तो यहाँ पे 1000 psi, देन यहाँ पे 500 psi और यहाँ पे 250 psi. ओके, सो this two phase zone goes towards the sinks when my temperature is decreasing at a constant pressure and my pressure is increasing at a constant temperature. So is it okay? So let's talk about crude oil itself. In both of the cases, when I decrease the temperature or increase the pressure, it will start to uh, goes toward the gaseous side and it will start to miscible with the vapor compositions or gas composition. Okay, so you can think in that way only, but you have to remember these things because like each and every time you cannot apply logic, you don't have that much time also, so these kind of things you can remember the visualizations and according to that you can answer. Okay.
सर
Yes.
सर अभी कोई पर्टिकुलर सब्सटेंस होता है तो हम उसका उस पे प्रेशर लगाते हैं तो उसके
One.
इंटरमोलेक्युलर फोर्स बढ़ता है तो
No. Here we are not talking about one substance. Here we are talking about the combination of substance only, na? C7 plus uh,
यस
the,
सर
we are not talking about here regarding to pure component. We are not talking here regarding particular methane only. Okay. We are
यस सर
talking here in terms of that mixture, na? So let's say here this has a different composition than what this has. There are possibility na, like let's suppose consider constant C1. Okay, I'm considering not a constant C1. I'm considering constant C7 plus. Okay, at this line only I'm considering also it may be 50% something. Okay, consider this point and this point.
ओके सर
So at this moment, let's suppose C2C6 has these percentages. We can say higher percentages, 80%, 80%, and compared to that, let's consider C1. So we are changing composition percentage itself, and it has an impact on that only. We are considering in that way. Okay. So maybe at 80 degrees Celsius, the two-phase zone with we are getting the whatever two-phase zone for these three combination is at this point, this point, this point, this compo with respect to this pair of composition, na, that will go towards sink side and we will get at a different composition at each point. Na?
यस सर
So I'm talking about in that conflicts only. Okay. We are not talking about any pure composition here.
ओके सर
Okay. So this understanding is again required because in EOR this kind of question ही बनेंगे और हर बार एक पेयर तो आता ही है कि सबका मेजर प्रिंसिपल क्या है, वो तो आप आंख बंद करके भी अब आंसर कर सकते हो. ठीक है. सो ये था हमारा बेसिकली टर्सरी डायग्राम. इसके बेसिस पे ही अब नेक्स्ट लेक्चर पे पूरी कहानी चलेगी. सो इसको अगर समझ में नहीं आया तो डाउट्स लिख लो और एक बार अच्छे से रिवाइज कर लो, पढ़ लो. ठीक है. देन वी विल स्टडी दैट ऑल थिंग्स. यहाँ पे आपको ईच पॉइंट पे क्या घटना बन रही है वो समझना जरूरी है पहले. और वो जो क्वेश्चन है आज का उससे में भी आपको कंपोजिशन का कैलकुलेशन क्लियर हो जाएगा. वो बहुत हार्ड भी नहीं है, बहुत इजी भी नहीं है. अगर लॉजिक पकड़ लिया तो इजीली हो जाएगा, नहीं पकड़ लिया तो टाइम लगेगा बहुत. बट वी विल डिस्कस आंसर टुमारो. आई विल सेंड दैट आफ्टर द लेक्चर विद दिस नोट. So the next I would like to discuss is type of miscibility, or we can say miscible flooding. So fourth one is principle of miscible flooding. So what we are doing here, we are injecting gas. So let's, I think I've copy pasted or not, I don't know, even it's not. So let's add one figure here and understand principle from that only, and we can conclude this session. Uh, tomorrow we will start with types of that. Okay, so this is the profile for a miscible flooding. Okay, so whatever equipment we required, it's already available in this photo. This is well sufficient to explain. So what is here it's indicating. So initially what we had that something like this, oil, gas, water, something like this. अबो ऑयल होगा, बिलो वाटर होगा और अबो गैस होगा, ठीक है, गैस ऑयल वाटर होगा। फिर हमने क्या किया, फिर हमने यहाँ से कुछ इंजेक्ट करना स्टार्ट किया और उससे क्या हुआ, मोस्टली ये जो इंजेक्शन है वो कहाँ पे है, यहाँ पे हमें ऑयल जोन में ही दिखा रहा है। ओके, यू कैन सी ना, दिस इज एंटायर ऑयल जोन। तो हम ऑयल जोन में क्या कर रहे हैं, कुछ इंजेक्ट करवा रहे हैं। इसके ऊपर में भी गैस जोन हो सकता है, इसको बिलो में भी वाटर जोन हो सकता है। ओके, तो पहले क्या होगा, इनिशियल केस में क्या होगा, हर जगह पे क्या होगा, ऑयल होगा। यू कैन कंसीडर दिस, ऐसा होगा कहाँ पे, यहाँ पूरे एरिया में। ओके, अब क्या हुआ, जब हमने इंजेक्ट करना स्टार्ट किया तो हम मिसिबल फ्लडिंग में क्या करते हैं, मिसिबल फ्लडिंग में हम पहले इंजेक्ट करेंगे, पहले ऑयल था, उसके बाद हमने क्या किया, मिसिबल फ्रंट को इंजेक्ट करेंगे। ओके, और यहाँ पे पहले ऑयल था, उसके बाद आ गया वो ऑयल यहाँ पे है क्योंकि वो उसको धक्का मार के वहां तक ले गया है, प्रोड्यूस किया है उसने। ऑयल के बाद है ऑयल बैंक, यू कैन सी हियर ऑयल बैंक और मिसिबल फ्रंट। ओके, तो ये वाले जोन पे क्या हुआ होगा, ये वाले जोन पे तुम्हारा जो तुमने जो भी इंजेक्ट किया, इट में बी CO2, N2, यू कैन से LPG, अल्कोहल, ये सब इंजेक्ट करेंगे। वो हम कल देखेंगे कौन कौन से होते हैं वो सब्सटेंट एंड कैसे मिसिबल होता है वो। हर कोई एक जैसे तरह मिसिबल नहीं होते, हर किसी का मैकेनिज्म अलग है, बट ये कॉमन डायग्राम है। यहाँ पे क्या होगा, ऑयल के साथ मिसिबल हुआ होगा, क्या मिसिबल हुआ होगा, जो भी गैस हमने इंजेक्ट किया, लेट सपोज यहाँ पे हमने CO2 इंजेक्ट किया, तो यहाँ पे CO2 प्लस ऑयल क्या है, मिसिबल हुआ होगा। ओके, तो ये यहाँ पे कुछ कंसंट्रेशन हमने इंजेक्ट किया होगा फ्रंट का। ओके, मिसिबल सब्सटेंस, लेट सपोज CO2 यूज कर रहे हैं तो CO2 के पर्टिकुलर कंसंट्रेशन को यहाँ पे इंजेक्ट करवाया हुआ होगा, और वो पर्टिकुलर कंसंट्रेशन ऑयल के साथ यहाँ पे क्या हुआ है, मिसिबल हुआ है। उसके बाद क्या है, उसके बाद है ये वाला जो CO2 है। ओके, वो दोनों के साथ मिसिबल हुआ होगा। आगे आगे ऑयल को हम ले जा रहे थे, तो यहाँ पे लेट सपोज CO2 इंजेक्ट किया तो ऑयल के साथ भी मिसिबल हुआ होगा, और पीछे जो वाटर है उसके साथ भी मिसिबल हुआ होगा। तो यहाँ पे यू कैन कंसिडर समथिंग लाइक दिस, तीन है, यहाँ पे क्या है, प्योर ऑयल है, यहाँ पे मिसिबल जोन है CO2 प्लस ऑयल का, यहाँ पे मिसिबल जोन है CO2 प्लस वाटर का, बट इट मस्ट बी हायर मिसिबल इन ऑयल विथ रिस्पेक्ट टू वाटर। डेफिनेटली थोड़ा बहुत वाटर के साथ भी मिक्स हुआ होगा। देन अगेन हम इसके बाद हमने जो मिसिबल गैस इंजेक्ट किया, ठीक है, इनिशियली क्या था, पूरे में ऑयल था, फिर हमने क्या इंजेक्ट किया, गैस इंजेक्ट किया, और वो जो भी गैस इंजेक्ट किया वो मिसिबल हुआ ऑयल के साथ। अब ये मिसिबल हुआ तब क्या यहाँ पे घटना बनी, तब यहाँ पे ये ऑयल के साथ मिसिबल होते ही यहाँ पे इंटरफेरेंशियल टेंशन को जीरो करने की ट्राई करेगा, और ये मिसिबल हुआ, दैट मीन्स ये ऑयल की विस्कोसिटी को भी क्या करेगा, कम करने की ट्राई करेगा। और अब ये ऑयल फ्लो होने के काबिल हो गया है, बट डेफिनेटली अभी भी उतना अच्छा माइक्रोस्कोपिक इफिशिएंसी नहीं होगा। तो हम क्या करेंगे, हम यहाँ से फ्रंट के बाद क्या करेंगे, मिसिबल सब्सटेंस इंजेक्ट करने के बाद इसको धक्का लगाने के लिए क्या करेंगे, वाटर को भी थोड़ा ड्राइव के यूज पे इंजेक्ट करवाएंगे, या फिर यहाँ पे नेचुरल ड्राइव वाटर की हेल्प मिल रही है तो वो भी हो सकता है, ठीक है। बट नॉर्मली हम यही प्रोसेस फॉलो करते हैं। हम पहले मिसिबल गैस को इंजेक्ट करेंगे, वो मिसिबल होगा ऑयल के साथ, फिर हम ड्राई वाटर यानी कि जो वाटर धक्का लगा रहा है वो वाला इंजेक्ट करेंगे, ताकि ऑयल वेल की तरफ इजीली प्रोड्यूस हो जाए और इससे माइक्रोस्कोपिक एफिशिएंसी इंक्रीज हो जाए। बट बेसिक फंक्शन यहाँ पे क्या है, इंटरफेरेंस टेंशन जीरो हो रहा है और ऑयल विस्कोसिटी कम हो रही है, ठीक है। तो दिस इज द प्रिंसिपल, इसमें कुछ उतना है नहीं, बस यू हैव टू रिमेम्बर इसका मेन फंक्शनैलिटी IFT को जीरो करना है और ऑयल विस्कोसिटी को कम करना, बट मेजर इज दी IFT को जीरो करना। IFT को जीरो करेंगे दैट मीन्स वी आर इंक्रीजिंग कैपिलरी नंबर, and viscosity को कम करेंगे, that means we are improving the mobility ratio. So this again correlated with those two terminology also, but this is the principle. So any doubt then you can ask me regarding to principle.
No doubt, sir.
या बहुत इजी है, उतना प्रोसेस में कुछ उतना है नहीं, बस उस अब ये मिसिबल कैसे होगा? क्या ये जाते ही सीधा मिसिबल हो जाएगा, जाते ही सिंगल फेज बना लेगा, या जाने के बाद ये पहले डबल फेज में रहेगा, फिर कुछ प्रक्रिया होने के बाद ये मिसिबल होगा? वो अब नेक्स्ट टॉपिक पे कवर होगा। दैट इज सिंपल, फर्स्ट कॉन्टेक्ट मिसिबल, मल्टी कॉन्टेक्ट मिसिबल। ठीक है, अब मल्टी कॉन्टेक्ट में भी ये अगर टू फेज में रह रहा है तो फिर वो ऑयल के साथ वेपर में से लिक्विड में जाएगा कि लिक्विड में से वेपर में जाएगा ड्यूरिंग दिस मिसिबिलिटी, उसके बेसिस पे दो और ड्राइव। ठीक है, दैट शुड बी, वी विल कवर दैट टुमारो एंड वी विल फिनिश दिस एंटायर miscible and immiscible flooding, whatever injection we have like LPG, CO2, N2, that we will cover tomorrow. But this is the
Hello,
basic
sir.
concept which, yes, go ahead.
Sir, can I stop the recording or?
Yeah, now you can stop.